We start with an overview of the ways you can compute a limit. Specifically, we're talking about the case when f is made up from familiar functions, and not when you're working with, say, a graph, or a table of values, or some other partial information. First, you want to consider whether f is a piecewise function, and if so, whether c is a transition point in the definition of f. If so, you're going to want to compute the left and right limits, and then compare them. If they're not equal, the limit does not exist, and if they are equal, that's the value of the limit. If it's not a piecewise function, you should try the substitution method. If you get a proper number, with no infinity, no division by zero, nothing else fishy, then that number is the answer. If what you got's not a proper number, you still have to consider whether it's an indeterminate form or not. If it's not an indeterminate form, like 1 divided by 0, or infinity divided by 0, or something like that, then you should think carefully about the one-sided limits, if they're growing, if they're shrinking, and about the signs of the two one-sided limits. If it is an indeterminate form, then it's time to use the strategies we've been developing in this video set, an algebraic strategy or the trig limits. And in the next video set, you're going to learn about the Squeeze Theorem, which is one more tool for evaluating indeterminate forms, but it's not as common as the ones we've developed here. Let's get some more practice by going through these extra examples. Start by deciding which of these 6 limits you can evaluate with the substitution method. For the first limit, the substitution method gives sine of 0 divided by sine of 0, which is 0 over 0. This is the most common of the indeterminate forms, so we see we can't use the substitution method. We're going to have to work harder to do this limit. However, in the top right, cosine of 0 in the denominator is just 1, so we get 0, and that's a regular proper number, so we're done. The substitution method has given us the answer. In the middle left, when we plug in x equals 1, the thing inside of the arc cosine is just 0. So now we have the task of computing the inverse cosine of 0. Remember, inverse functions are really a question. This one says, what angle has cosine equal to 0? Now, there are a lot of angles that have cosine equal to 0, but we mean the one that's in the range of inverse cosine, which goes from 0 to pi. So what angle between 0 and pi has cosine 0? It's pi over 2, and we're again done with a careful application of the substitution method. However, in the middle right, when we plug in x equals minus 1, we see that the thing inside the inverse cosine function is an indeterminate form. So we're going to have to look more closely at that. In the bottom left, we have absolute value, which is secretly a piecewise function. So we're going to need to consider left and right-hand limits there. And finally, in the bottom right, we get 0 over 0 again. Now pause the video and try to evaluate each one of these 4 that we haven't completed yet. Okay, first step, we have this limit of sine 3x over sine 2x. If we think back to the examples we did about trig limits, you'll probably remember that we want to use the basic limit laws, and we're going to separate things out so that we get sine of 3x with 3x, and we get sine of 2x with 2x. Each of these limits then is going to go to 1, but their product isn't exactly what we have on the left. What needs to go there in the pink box to make these equal? What we need is a 3 halves. So when we take the limit of each piece here, we're going to get 3 halves times 1 times 1. For the arc cosine problem, the thing inside the arc cosine has an indeterminate form. So we're going to have to figure out what the limit of that inside thing is first. Since we get 0 over 0, it's a good idea to try factoring. Now on the top and bottom, an x plus 1 cancels out, and we're just left with x minus 1 over 4, and then substitution gives negative 2 divided by 4, also known as minus 1 half. So the original limit is the inverse cosine of negative 1 half. What is the angle between 0 and pi whose cosine is minus 1 half? it might help you to look at this unit circle and see that the answer, theta, is going to be in the second quadrant. Specifically, we get 2 pi over 3. Now for the third limit here with the absolute value, it's important to recognize this as a piecewise function. If you don't, and you just try regular substitution, you might think of this as an indeterminate form, infinity minus infinity, and then your instinct should be to try to combine terms. But actually, since this is piecewise, what we want to do is look at the left and right hand limits separately. In the right hand limit, x is positive, so the absolute value of x is just x, and the function here is 0, so the limit from the right is 0. What about the limit from the left? Well, when x is negative, absolute value x is minus x, so we have negative 2 over x. And now since x is negative and tiny, this limit is going to positive infinity, because we have a negative numerator and a negative denominator, which is getting really close to 0. The left and right hand limits don't match, and hence the two-sided limit does not exist. The last limit gives us 0 over 0, so we would like to try factoring. But we need the numerator to be in a nicer form in order to be able to do that. So let's start by making a common denominator up there. This is totally factored, and we're still getting 0 over 0. Plus, we see a square root, which reminds us of conjugates. So the next step is to multiply by the conjugate of 2 minus square root x on top and bottom. The conjugate is 2 plus square root x, and when you multiply these things together in the numerator, you get 4 minus x, which is the negative of that factor x minus 4 we see in the denominator. So they cancel out to make negative 1 on top, and the remaining factors in the denominator. Now we can finally use substitution, and we just get minus 1/16. Hopefully you can see from these examples that being able to identify which forms are indeterminate and to decide which strategy to apply is as important as knowing how to apply each strategy.